Okay, let us move on to beam question. So here I take one question from the textbook. We have a beam. Okay, let me draw here. This is the beam, and it is fixed at one end, and then the load is applied here. The F is 5 kilonewton. This is the note given here is 1, and here you have a roller support, and you have note 2 here, and at the fixed end is note 3, and the length is 6 meter and 6 meter, and the E is given equal to 210 gigapascal, and the I, the moment of inertia, is 4 times 10 to the power of -5 meter to the power 4. Okay, so you need to find the displacement and slope at the nodes. Okay, and the force in each element and the reaction. Okay, so you need to find this the displacement and slope, and then you need to find the deflection lah. Okay, so again, just to recall, for any structural problem, either beam or truss, the equation we have is F, the force metric, equal to the element stiffness metric time the displacement metric, the nodal displacement metric. Okay, so for beam, F here is shear force and moment, bending moment, and for U, the nodal displacement for beam is the vertical displacement V, or displacement in Y direction, and also the theta, or the slope or the rotation. Okay, these two is caused by the force here. Okay, alright, so this is the only difference between beam and truss. For truss, remember the F, your F is the force in X and also in Y direction, and for U in truss is the displacement in X direction, which is U, and the displacement in Y direction, which is V. Okay, so for but for beam, again, the F is a shear force, which is denoted by F, and bending moment denoted by M, and for U, the displacement or the deflection is vertical displacement V, and rotation theta, or you can call it the slope. Alright, okay, so if you notice, similar to truss, the DOF, or the degree of freedom, at each node for beam, it has 2 degrees of freedom. Okay, the V and the theta. Okay, for truss, you have U and V. Also, it has 2 degrees of freedom at each node. Okay, alright, so that means, for example here, for node 1 you should have V1 theta 1, for node 2 V2 theta 2, and for node 3 similarly you should have V3 and theta 3. Okay, and also at this node you should have F1, M1, F2, M2, and also F3, M3. Okay, so let's start to solve this problem. Okay, so remember the element stiffness metric for beam is equal to E I over L cube, and then you have this metric. Okay, 12. So you just need to plug in the value, and then you can get your K. Okay, 12, 6L, negative 12, 6L, and then 6L, 4L square, negative 6L, 2L square, negative 12, negative 6L, 12, and negative 6L, 6L, 2L square, negative 6L, and 4L square. And your L is the length of the element. Okay, so let's start with element 1. Element 1, so K1 is, so just substitute your E, okay, your E, your I, and L. So you should get here 3.989 times 10 to the power of 4, and then you just need to substitute all the, you plug in the L, you can get the value. So you should get 12, 36, negative 12, 36, 36, 144, negative 36, negative 72, negative 12, negative 36, 12, negative 36, 36, 72, negative 36, and 144. Okay, alright, so this is your K1. Now for K2, if you see, let's see again the question, the figure. Okay, if you notice, element 1 and element 10 is exactly the same, so your K should be the same for both elements. So basically K2 is equal to K1. Okay, so now we get both K for both elements. Now we want to find the global K. So the global K, we just propose those two element K. Okay, so the global K is just, you need to suppose lah. Okay, so basically this is for element K, element 1. It will, so for element 1, remember this is V1 theta 1, V2 theta 2, right? So it will the node that intersect with the element 2 is basically this component here lah, the node number 2. Okay, so your basically your K2 will be here. Okay, so you just need to add this point, this component here between so you need to add with this lah. This is for K1, okay, and K2. So V2 theta 2, V3 theta 3. Okay, so I think you by now you already you know, master of this superposition. So you just need to add with this lah, okay, because it's exactly the same. So you just need to add these two. Okay, so your global K will be 389 times 10 to the power of 4, 12, 36, negative 12, 36, 0, 0, 36, 144, 36, negative 72, 0, 0, negative 12, negative 36, 24, 0, negative 12, 36, and 36, 72, 0, 288, negative 36, negative 72, 0, 0, negative 12, negative 36, 12, negative 36, 0, 0, 36, 72, negative 36, 144. So this is your global K. Okay, alright. So now we have to apply the boundary condition. So based on the figure again, what we can apply is, okay, at node 1, we know that M is 0, right? There's no moment there. At node 2, also M is 0. Okay, and at node 1 again, our F1 is 5 kilonewton. At node 3, your V is 0, your theta is 0. Okay, alright. So basically we have 5 boundary condition that can be applied. Okay, so let's plug in and then we can simplify the equation lah. Okay, let us write again the equation. So you have your F is F1, M1, F2, M2, F3, M3. Okay, and then K, this is your K, double K, and then the U is V1, theta 1, V2, theta 2, V3, theta 3. Okay, alright. So we know that our boundary condition, so V1, F1 is 5 kilonewton, M1 is 0, M2 also 0. Okay, at roller or pin support, M is always 0 at the moment. Okay, and then you have, what else you have? You have V3 0, theta 3 also 0, and another one you have the V2, okay, at the roller is also 0, right? So basically we have 6 lah. 6 boundary condition that can be applied. Okay, so now we can simplify the equation. Alright, so let us strike what is 0. So again, this is v1 theta 1, v2 theta 2, v3 theta 3. So your theta 3 is 0, so we can strike out. v3 also 0, we can strike out this. v2 also 0. So this one is here, right? Okay, that's all. And then just to remind, you have 3 nodes, right? You have 3 nodes, so your global K should be 6 times 6 matrix. So here you get it right lah. Okay, just to double check. Okay, all right. So now we can simplify our equation. Okay, so you have 5. So it downwards, so negative. Okay, negative 5,000 Newton, and then you have 0, 0 equal to K. You just need to remember to plug in your K, and then your, okay, let me write the K here so that we can see. Okay, so your K now is 12, 36, 36, 36, 144, negative 72, 36, 72, and 288. Okay, so this is your K, and your U is V1, theta 1, and theta 2. Okay, so now you have 3 equations with 3 unknown. 3 equation and 3 unknown. You should be able to solve this. Okay, so you should get, let me check the answer. You just solve the equation. Okay, the answer is let me check first. Okay, your V is negative 0.075 meter. Your theta 1 is 0.0161 radian, and theta 2 is 0.0536 radian. Okay, all right, so basically we are done. It quite simple actually. What you, again, I just to revise again. Okay, what you need to do is, first you need to find your K, the element stiffness metric for each element. Okay, and the equation is given specifically for beam and also for truss. It has its own equation, so you just need to use the equation and then just plug in the number. Okay, so you find your K, the element stiffness metric, and then next is you just need to find the global K by using the superposition. Okay, this is your global K. This is your global K, and then after that you apply your boundary condition. Okay, apply the boundary condition, and that will simplify your equation. And then from that, supposedly you will be able to solve the for the unknown lah. Okay, so that's all lah. So we are done. If you have any question, you can try by your own. I will of course I will post this on Alien. You can try by your own, and if you have any question, or if there's something that are not clear to you, you can always ask me. Okay, so that's all. Thank you.